So welcome, I'm Greg. So this is on SQL Server performance tuning issues and configuration issues in around SQL in a VM. How many were in the session this morning? Just so I noticed that, yeah, pretty much everyone. That's great. So look, so that means I don't have to tread over territory where we did a lot of that this morning. But what this is looking at, what I really want you to get out of this session is to be comfortable with how you would configure a VM if you're using SQL Server in an Azure VM. That's the key thing we're looking at here. How many of you have done that as yet? Just so I get an idea. Using, not much. Okay, so all right, so new territory. So look, what I want to cover off here first up is just talk about what it is that SQL Server needs, and then have a look at what it is provided in the VM environment in Azure, and look at the choices that we have for how we would configure it, and then finally, what do we do to sort of do ongoing monitoring and troubleshooting in around that style of environment. And so first up, if we look at what SQL Server needs, if I look at where do performance problems come. Now, one of the things I find fascinating, I often read content from product support and areas like that, and they say, here are the most common performance problems that people run into with SQL Server. And every time I read those lists, I think, you have to be kidding, right? And I think what it is that the vast majority of problems are dealt with long before they ever go near product support. And so what they see is the most bizarre stuff, and of course that's what they see every day, so that's what they think is normal. So if I look at, when I go into customers, and we often end up there where they say, look, I've got some sort of performance problem with the database. If I think about what are the issues I run into, number one's app design, right? Bar none. You know, I mean, nearly every time, the most prevalent issue will be something to do with how the application's designed. The second is app design, right? And in fact, the third is app design, right? So now, there's nothing about an Azure VM that changes that in any way, right? Once I get through those, then it's things like indexing that won't be appropriate. We may then start into concurrency and blocking type issues. Now, most of the time, the curious thing is we get called into sites and they say, I've got this blocking issue. What they mean is it's going boom all the time with deadlocks and stuff like that. That's usually what they're actually meaning. But whenever I look at that, the real problem is that the queries are taking forever to run. In fact, it's pointless looking at the blocking issues until we go and fix all that. And once you fix the issues with the queries and stuff and everything design-wise that runs quickly, then usually 99% of the blocking issues disappear anyway, right? So long before we then start dealing with that. It's only then that I start running into issues around platform configuration. And so the message I'm trying to give you here is that what we're talking about is how I configure the platform. Yet if you think about most of the things that are going to cause you performance problems, they're all things that are common, whether you're talking about in an Azure VM or not, right? They're not issues around the platform configuration. That's kind of the fine degree once we get to that. And finally, of course, you might get situations where SQL Server's not making a brilliant choice, you know, in terms of the execution plans and things, and we might have to intervene in some way. But super important is on premises or in an Azure VM, app design is the number one thing you need to deal with. That issue does not go away. And I say that because people seem to get this idea that when they're pushing things up into Azure, it's like some sort of supercomputing structure or something that's suddenly going to fix their issues. I mean, that's not the case, right? I mean, at all. And those issues are still there. Now, if you look at what SQL Server wants, it wants enough CPU, first up. Now, most sites I go into today are not CPU bound, right? Have any of you come across situations where you are CPU bound at all? It's pretty rare, right? Now, if I see that, it's usually something else wrong. So it could be there are issues with recompilation of query plans and things like that. There are things that can cause like plan cache pollution and so on. There are issues that can lead to that, but they're not so common. But if you have a CPU bottleneck today, that's usually something more along those lines. In fact, I did a white paper that I've updated for 2012 recently called Plan, Caching and Recompilation in SQL Server 2012. It's a long, long article, just talks to death about all the stuff that covers off that. So if you do have issues around CPU, go and read that. That'll cover a wealth of things. Enough memory has been an issue, right? Now, this is an area that is changing really rapidly. Now, in the session I did yesterday, I was talking about tabular and multidimensional models in analysis services. But all of these things are trending towards a situation where previously we'd lay data out on disk, we'd work out how to optimize it appropriately in structure, we'd try and build appropriate indexes, we do things like that. The current approach, more and more, is that we compress the life out of it and then we just do brute force stuff in memory. Now that's a complete shift in how we're building applications. It's much faster, much simpler, but again, it takes a lot of memory when you start doing this. In fact, in the hardware sizing guide that I was part of for Analysis Services Tabular, the team said, would people think it's odd if we suggested a terabyte minimum of memory? And I went, hang on, like most servers I come across today, that's not reality, right? But this is where that thinking is sort of heading down towards that direction. So look, memory is going to be a big issue. In 2014, we've got clustered column store indexes. Out of all the things I've seen in 2014, that's the one I think has the most potential to make a radical difference to how you build applications. Because what we're talking about is taking tables and instead of doing clever index design, we're sort of squashing the life out of it so that the thing fits in memory and stuff is happening in brute force. And it's not a non-clustered index like we had in 2012. This is the copy of the data, right? So this is another way of storing this. Now, it completely performs brilliantly when most of that fits in memory, right? Now, many sites I'm also going into have situations where entire databases are starting to fit in memory on some servers. Now, I see people like the Fusion IO guys are probably here at the event. Now, and devices like those can make a huge difference to IO. But when you get to the point that most of the data is sitting in memory, then all of a sudden these things it's far less of an issue. Now, this is only going to get more important going forward. I think Dandy would have done a session yesterday talking about 2014 with Hackathon, and what they're doing there is they're saying, well, look, again, if we have memory-based structures where most of the data fits in memory, we can completely redesign how SQL Server works. It's all been based in the past on the premise that everything lives on disk, we bring into memory the pieces that we're wanting to work on at the time, and we've used lots of locking and so on to deal with concurrency. The approach in future is to bring this stuff into memory as much as you possibly can to run completely optimistically, where you're not actually using locking to deal with this and just doing an optimistic approach and just go fast and hope for the best and deal with the problems when they occur. But this leads to a sort of a lock-free behaviour, and this leads to a very, very fast outcome in many situations. Now, what's different about that one is that they wanted to do that in the process space of SQL Server. So when you create a table in Hackathon, what you're doing is you're giving a definition that then creates a DLL in the background that then has all the code for how to deal with the table, and that just interacts directly in the memory space of SQL Server. So this is a radical difference in how it's done. When you create a stored proc, one of the atomic native stored procs, it now compiles down to a DLL, it sits in memory, and it's razor sharp inside in memory. So this is going to increase rapidly, the effect of having memory in the machines. But it's not so much of an issue as yet. What we do need today typically is a responsive I/O system. Most systems I get to are I/O bound today. So anything you do that cuts that down makes a big difference. There are three things we normally look for. First is latency. And so this is when I issue a command, how long is it, even if it was doing next to nothing, before that will come back? Now, one of the reasons people are using more and more direct attached storage of really fast devices is that even in high-end devices, that's got down to about 5 and 10 millisecond type numbers. For SQL Server, we normally say for a data file 5 to 10 milliseconds. For a log file, they talk 0 to 5. But it's hard to get that number down because there's just an overhead in the chain of the I/O. Now, what's happening, of course, with the fusions and the folk that are doing the in-memory versions of this stuff is suddenly they're talking 68 microseconds, not anything in the ballpark that you're talking. Now, that has a profound impact on latency. But when you go into an environment where potentially you're running something to a data center a distance away, latency can suddenly become the biggest component of what you're doing. Now, I'll give you a quick look at that. And so what I've got here, I've opened Management Studio and connected to a SQL database there. Now, it may have timed out, but we'll find out. And what I normally do is just do a command that has no computation time. But then in query, options, then I'll go in here and turn on the client-side statistics. And if we execute this, then if we look at the stats, then this is the stuff I'm interested in, right? So what we've got here, I'm going to make you seasick, but the first part here is the client processing time, then the total execution time, and the wait time. But note here that where I've got this, the client execution time is now kind of like the tiniest bit of this, and the total time is spent so much time waiting. So the thing I was stressing in the session earlier this morning is you have to avoid anything that has any sort of chatty behavior. That's just going to cause you performance issues like you wouldn't believe if you don't avoid that in the first place. So you've got to kind of minimize the round trips to the server every single time. Now, this gets more interesting when things like the I/O and the storage, in some cases, is going to be somewhere else as well. And so we have to be thinking all the time about what that means in terms of latency. And where it used to be a small component, increasingly it's a big component. Now, there's also I/Os per second, and this is a measure that's sort of saying how much overhead is there in the software that processes the I/Os. And so there'll be a hard limit at some point on just how many operations you can get happening on a particular channel. And then we've got throughput, which is a measure of the overall amount of data that can travel there. And often there'll be some sort of bottlenecks associated with that as well. The CPU and memory stuff is basically unchanged when we move into an Azure VM, but obviously the I/O stuff is still an issue. Now, if you look at when SQL Server reads data, when it gets a select from an app, the first thing it's doing is looking in the buffer to find out if it has that page already there. If it doesn't have the page, it's got to go and sort of get that from the underlying system, then return the data back. But the important thing is the more stuff we have in the buffers, clearly that makes a huge difference to the outcome of this. Now, another thing they've done in 2014 is they've given us the ability to expand, if you're doing things on premises, the apparent amount of buffer cache that's there. So we've got an option to do buffer pool extensions at the server level, and so I can take a local SSD, even if I'm using a SAN for the other stuff, and say I want to use this as part of the buffer cache on the machine. So that's now a server configuration as well in 2014. So I could have like a second level cache that's not as fast as a normal one, but pretty good. But then if you look at a typical OLTP data files, if you look at the mix of reads and writes, mostly reads in most of these systems. Now, again, this is something I find very odd when I talk to clients. If I talk to clients and I say, what percentage of your time does your system spend writing as opposed to reading? Invariably, I get told numbers like 20%, things like that. In fact, I was working on even a white paper with Microsoft recently, and one of the guys I was talking to was talking numbers like 40%. And I was just saying, look, where do you see this, right? I mean, when I test this, what I see at real sites is 2%, 1%, 2%, numbers like this. So one of the things I tend to do is I tend to build more in the way of indexes and things than I find most other people do. Highly targeted, but I want to optimize for the 98% case, not for the 1 or 2, right? And the irony is people will say, oh, the more indexes you have, you'll impact update operations, but that isn't necessarily true either. I mean, you have to find something before you can update it, right? I mean, usually what they're talking about is simple primary key updates or something, yeah, but that isn't always how it works, right? And so you'll often get even missing index hints from update statements, right? And so there's clear evidence that that's the case. Now, in terms of the writes on a data file, they're pretty much asynchronous stuff going on. It's not a lot of rows, and the typical I/O size is 8 to 64K is the sort of number. The pattern is mostly random, and you'll usually have a lot of users doing it at the same time. Where an OLAP file, the difference will be that you might have a high number of rows involved in the I/Os, and notably the I/O size can be up to megabytes. Now this is something that differs depending upon the edition you're running. I often look at people and they say, what's different about Enterprise Edition? Well, one example is that it can string reads of up to, I think at the moment, about 8 meg. So these are very, very big reader heads and things like this. Now, again, if you've got enough memory to make use of the buffers, that can have a profound impact, even without changing anything else except the addition. The I/O pattern is mostly sequential, and the difference with the writes is we're talking usually synchronous. We're waiting for it to happen. And, mostly async if we're still talking OLAP, and we've got concurrent users at that point is usually pretty low. Now, if SQL Server modifies data though, so when we get a modification, we again find the page, make sure it's in memory, then it's changed and latched, so there's a latch saying, hey, this has been modified. What's written out to the log then are details of the change that occurred. People get the idea it's like the SQL statement written out. That's not the case. People also think it's the page written out. That's not the case either. It's just details of the change that occurred. Now, it depends on the model, the recovery model you're in, as to really what gets written out there. But most of the time, if you're in full recovery, that's what's going on. Now, we're waiting for that to occur, and then when that comes, then we tell the application that it's done. And sometime later, the checkpoint process comes through, picks up the dirty pages, and writes them out to the disk file. So this is completely different behavior on the log file to what we have on the disk file, on the data file. So with the log files, we're talking about mostly writes. We're talking synchronous, so we're waiting for it to occur. It's low number of rows per I/O. The I/O size is sort of 8 to 64K, but the pattern is mostly sequential. So it's quite different. Now, if we look at what we get from an Azure VM, if you look at the structure of this, the top layer, I suppose, in the hierarchy, which is shown in the bottom here, is the region, right? So we have different regions we work against. Now, in that case, when I did the latency, I was going against Singapore today when I tried that. One of the things you need to do is decide the region that you're going to work with. Now, it's not, of course, geographically closest. That's the issue. I've done work in Auckland, for example, and central US for one of those was the lowest latency. It totally depends upon where your ISP routes their cables and what's connected to what, right? So don't just look geographically, measure to the different data centres. But this will be a much better story, of course, when we have ones in Australia. Now, within that region, you can have a set of data centres. The data centres are then structured as a whole series of clusters inside that. Every time you spin up a VM, you make a decision about what is exposed externally. And this is what a cloud service is. And so a cloud service is a grouping of objects that have an external presence. So I could have an external address for each of the VMs, or I can create a cloud service that hosts multiple VMs. It's the first concept here. And we mentioned in the session this morning the size of these things. Now, I said they had small, medium, large. They've gone now up and down into larger sizes. But note the amount of memory here. So we're still 56 gig. Now, in the brave new world, that's not that big, right? But in terms of spinning up VMs in the cloud today, that's a good story compared to what most people do. But it's still not where we're heading. Things are going to get bigger than that. Note you're limited by bandwidth as well, depending upon the size of what you purchase. And it changes the number of disks you can attach. The other thing is that you'll find that in the Azure storage, you get around 500 IOs a second per object, right? So per disk that you end up provisioning. So you need to be thinking in terms of that also will affect the throughput that you could potentially get in IOs per second. So at the high end at the moment, it's about 16 by 500, and that's where we top out today in those sort of machines. Now, there is another layer above that in that there's a limit per storage account, and that's up around 20,000 in terms of the amount of stuff that you can get through that. And so what I see some people try and do is use multiple storage accounts to try and improve the apparent throughput in this. Now, I'll talk more about in a minute why that's not such a great idea. Now, when you get the VM and you start it up on the first boot, what they do is they fail in the operating system from the storage. So it's based on a template, and they run the sysprep stage for Windows. So it's the sort of customization of Windows. Then they run the end of the SQL Server sysprep if you've picked a VM that has SQL Server as part of that. And what you'll find when you get it then is a couple of drives. Now, the first thing is the operating system disk. They'll have provisioned that as currently as 127 gig. It's optimized for what they consider operating system access. Now, that affects how the caching, the local caching, is configured. And it's persistent. So stuff you store to it is going to live. It's going to stay on. Now, the thing that might seem odd there in that picture, they've got a RAM cache in the virtual machine, but they also have a local disk cache. And people get confused. They go, isn't that the same disk, right? It's not. So what this is the operating system disk is a drive out in a storage account. The local disk cache is a local drive attached to the host that has the VM. Now that's shared across all the machines all the VMs that are on that same machine. You don't get to control the size of it, and the size of it is determined by the size of the VM that you've purchased, right? So this is used as an intermediate cache for local fast access and to minimize the number of transactions because you're charged for storage transactions to and from storage. So this is why they have that sort of local cache. The next thing you'll get is a D drive, and this is intended as the page file for your operating system. The most important thing about it is notice it's not persistent. So you look at it, and even though there's a bunch of space there, don't stick stuff on it, right? Because it can just go away, right? So do not put things on there. And this includes tempdb. We'll talk about that later. Now, so it isn't persistent. If the VM fails or needs to be recycled, the contents of it are gone. Now, this is provisioned again as an attached disk on the physical host. Beyond that, you then start creating VHDs in the storage account, and they become your additional drives. And this is the thing where we said we can have up to 16 of these attached, and this is what we need to use for our normal database storage. Now, if you look at the I/O subsystem here, again, this is very standard sort of Hyper-V type structure, where the guest operating system is working through the hypervisor and then wandering off to Azure storage, where this sort of blob store occurs. Now, inside the blob store, there's the storage location service determines which of the storage, literally, which location that's occurring in. They've got load balancer and stuff at the front end. There's then a partition layer, which is the thing that deals with geo-replication across different data centers. Below that, they have a stream layer that deals with what they call intra-stamp replication. This is the thing that deals with you having 3 copies of the stuff on the, within the current data center. And then stamps are what they consider get stored as storage below that. Now, when they provision this, they say they give you 3 copies of the data. The other thing they do is they go out of their way, of course, to make sure they're not side by side or in similar racks or things like that. So the idea is that they're not all going to fall over at the same time, even within the one data center. You know, they are actually quite well distributed. But you need to keep in mind that you are working with a sort of a shared multi-tenant system. So what this means is that you don't have the same sort of necessarily consistent performance. Obviously, the higher you go up, the more consistent that gets. You do have shared host machines, you do have shared storage under the covers, you do have shared network bandwidth, maintenance operations will occur in the background, and what you are doing is you're making a cost and I would say agility trade-off against that sort of control. And usually I think it's a very, very good outcome. Now, this disk caching is the thing that seems a little confusing. So I find people are sort of puzzled as to what's going on here. Now, as I said, this is local disk attached to the machine. And so the aim is to sort of minimize the transactions going on against the storage. And there is also a RAM cache, but that's shared between all the VMs on the machine. Now, if you set cache to read-only, and I think, again, people find this confusing because they're trying to think, how do I think about SQL Server caching? But in this case, all requests are cached, all requests, if you say read-only, but writes are persisted directly out to storage. They're still cached, but they're persisted straight out to storage if you choose that option. If you choose read-write, then what happens is all the read requests are cached. Some of the write requests are cached. It depends on whether the application has chosen write through, which SQL Server does, or not. And so if an application chooses write through, then it writes straight through to the storage. Otherwise, the other ones do get cached locally before they go out. Now, this actually gives you the lowest latency if you have a light workload. But as the size gets up, it's actually not the best choice. And so a cache setting of none, which sounds almost sort of counterintuitive, but that's actually the highest I/O rate you'll achieve, is by taking that one. And all of the disk transfers go straight to and from storage, bypasses the local cache, but note also, I've said you need to consider the transaction cost because you're running off and doing all the reads against things that you could have been caching locally to some degree in the local machine. That will increase your transaction cost there. But the thing is, often that path to and from the storage will outperform some of that shared local cache on the machine. So you'll actually get a consistent and higher I/O rate there. Now, the settings that you get to choose for the operating system disk, it defaults to read-write. It doesn't support none, and you can configure it to read-only. The temporary disk, the D drive, has no cache settings that you have access to, and the data disks, it allows you to configure caching for up to 4 drives, and that can be read-only or read-write, but the default for performance reasons is none. All right, so if you think about it, like, how do I configure this? So the recommendation is if you have a small database that's, let's say, up to about 10 gig in size, then they suggest just drop it on the C drive. It's quite fine. And so what you'll have there is that has read-write cache, you'll have tempdb, the system databases, the user databases and things, all on that C drive. And D drive will end up unused in that case, apart from, as we said, paging. If you have a bigger database, we say up to 1 terabyte of storage, and you're going to get acceptable performance by just going with a single attached VHD out of storage. It's a lot easier to work with if you only have one, obviously in terms of management, and it's a much simpler recovery strategy if you ever have to recover this. And so you end up basically with the OS disk for the read-write, you put tempdb and the user databases then on the E drive that we've attached, and we leave the D drive unused. And we've noted there some of the sort of typical I/O patterns and values that we've seen achieved out of this. And look, it's acceptable, it works quite well, and for many people that's entirely appropriate. If you go up beyond 1 terabyte, then you need to think about what is the best way to use multiple drives. Now, you need to get more IOs per second. We need to use additional drives. And the issue then is, what do? Do you stripe it in the operating system? The answer is don't, right? The suggestion is to avoid that. Windows Server 2012 has a thing called storage spaces. That's not a bad option, perhaps, for doing that. But the best options we've seen for dealing with this is if you get into SQL and you deal with its files and file groups and so on, and spread the load around appropriately using that, you'll typically end up with, by far, the best outcome. It's more design work. Now, and also, I suppose at that point, it's enterprise only as well when you get into petitioning. If you haven't done a lot of work with petitioning, how many are using petitioning in data files? Yeah, that's what I find, a handful. Look, I'd encourage you as well to have a look at how to do petitioning. There's a white paper called Table, Petition and Index Strategies, which is up on the MSDN site. It was done for 2008. I was a tech reviewer on that. It's a very, very good white paper. And it's about 60 pages long. Takes you through the basic things you need to know to do petitioning. It's not trivial. I won't try and kid you that. But it can have profound outcomes. The main reasons I look at using petitioning is, for a start, it allows me to have parts of a table read-only, for example. Now, I love this because I can have, for example, older data. I could keep maybe a sliding window where I've got month by month, and I could say every month except the current one is read-only. Now, the wonderful thing about that is, for a start, I know it's not getting changed. But also, when I do things like recover a database from a failure, I go into so many sites today where people are doing backups, and if they ever had to restore the database, they would be out of business before the restore finished. And in which case, why are you doing the backups? Like, well, what exactly are they for, right? And so the thing about that, you always need to think as the databases get bigger, is that I should be looking at some sort of partial availability. And so if I can restore particular file groups and I can access the most current data, it might mean I can trade. It might mean I can't run reports on old things. Well, so what? But at least I can probably trade. Petitioning helps you do that sort of thing. Petitioning makes a big difference in terms of being able to remove old data, say at the end of a month, lop out a month worth of data. That becomes a metadata operation instead of a massive operation. You can bring in big lumps of data that way. Again, a bank I was at in Melbourne a while back, they had a table that was only about 350 gig, but they were replicating it to Singapore, and they had a 1 meg link, right? And everybody else in the building was using the same link, And while replication ran fine, no problem. But of course, if it ever broke, this is a problem, right? So suddenly it was, how do I get that 350 gig to the other end? And of course, the only realistic answer was to do a backup, hand it to someone and say, have fun in Singapore, right? That's how it was going to get there. By using petitioning, we're able to sort of break it up, and if I know that none of the rest of the table has changed, I was then down to a couple of 100 meg, this is a completely different story, because it's now, how do I get a couple of 100 meg up to the other end, and I know the rest of it is exactly the same. That's now that's a problem of a entirely different order of magnitude. So look, there are also locking issues. That it makes a big difference in terms of lock escalation. That's to the petition level instead of to the table level, and so on. There are lots and lots and lots of things where it is worth getting your head around. You can also do things like different compression strategies. So I could have highly compressed page compression on the old data and just row compression on the current data, and so on. There's a world of goodness in petitioning. And so look, I'd encourage you, if you haven't gone and looked at that, it's a really important thing to have in your toolkit. But once you start breaking things up across multiple drives, and it could be even, as I said, the same table, using petitions, you can start to take advantage of a fair bit of space and get good amounts of I/O occurring. I put a chart in there. I don't expect you to read the whole thing. It's more just so that if you look at the notes later, you can see, look, this is where things scaled up and where they didn't. But as I said, this is a good way of achieving it. The other thing you might do, of course, is that it would be, in a perfect world, we'd have separate drives normally for each log file for each database. But who gets to do that, right? I mean, that almost never happens on premises. You can now do that, right? The only thing that would be a limitation there would be on the number of drives, would be the thing that would cause a problem. But you could completely isolate the log for each database by doing this. Now, there's a couple of other things that are issues in around the performance of this. And the first one is that we note this sort of disk warm-up stuff. Now, I haven't seen anything documenting this, but there seems to be some sort of layer of logic in the data centers where they start to bubble up the stuff that's being more used, right? And so if you're doing testing and things, make sure it's up and warm and running, maybe 15, 20 minutes before you start making assessments on how does this work, because we've noticed a change in behavior as that occurs. In terms of allocation unit size, they normally recommend with SQL Server that we format as 64K clusters rather than default of 4. We found in the Azure VMs it makes no difference. And so quite happily, just formatting these as 4K cluster size seems to be completely fine. If you're doing on-premises, it's important. And depending upon the version of the operating system that you formatted it with, it's also to make sure on premises that you've got partition alignment appropriate as well. Because drives that were formatted with, for example, Windows Server 2003, it's not aligned in a way that's actually helpful to you. So to Server 2008 and later, do the right thing. But there's a really good white paper from a friend of mine, Jimmy May, where he talks about partition alignment for disk partitions in SQL Server. And if you haven't read that, that's worth doing. And he's also got some scripts there that sort of show you how to check and make sure it's configured appropriately. That's also not an issue in terms of when we're running in this sort of environment. Now, as I said, you might consider using multiple storage accounts to try and increase the apparent bandwidth and so on. The hassle with this is that you don't get guaranteed write ordering across multiple accounts. You do within an account, you don't get it across accounts. So if you're trying to do that within the one database, don't go there, right? This is the sort of thing that could lead you into dramas. However, if I'm thinking about separate databases that don't have referential integrity issues between the databases or multi-database transactions, these sorts of things, by all means, you could run off and do this in different storage accounts. And so that might help a bit. But most of the time, the limits on the storage account aren't actually all that tight. But there is a limit on 200, as I said, 20,000 transactions a second per storage account. Now, data compression. I look at this, and again, so many sites I go into running the enterprise edition of SQL Server who are not using data compression. You need to use it. In 2008, I thought it was the best thing in the box, right, bar none. And so I see this all the time where people think compression means smaller and slower. It's usually smaller and faster. There's just not a downside. And so what happens is we're storing rows in a much smaller space. So you tend to cut the I/O dramatically in terms of the size of what's required I/O. Many, many more rows fit in the same amount of buffer in memory. And what we found in reality is that the CPU often even ends up going down. Even though it's higher per page, if you're dealing with a third of the number of pages, that can have a profound impact as well. So it's peculiar. But the thing about turning on compression is that when you enable it, it does nothing. It just sets a setting that says, next time I go to insert a row, if I'm going to cause a page split, if I compress it, do I avoid the split? That's what it's doing. So unless you do something that says, I'm going to rewrite all the data, then you don't see the outcome from the compression. So one of the things that you need to do is to go back and rebuild the tables and whatever to then really see the outcome. Now, one of the issues that came up with that is it's okay to rebuild clustered indexes, non-clustered indexes, these sort of things. But of course, you might have a table that was a heap. And so then you had the issue, well, how do I rebuild a heap, right? And what I used to see people do to get rid of forwarding pointers and things that you'd have in a heap is they used to add a clustering column to it, create a clustered index, and then just drop the column again. But they just wanted it to rewrite the entire table. You don't need to do that anymore. 2008, they added alter table with rebuild. And that can be used to rebuild the table or partitions of the table with different compression strategies. And that includes heaps. And so you have to do something, though, to cause that rewriting to occur. Now, it's quite different. If you look at things like encryption, when you enable encryption, it triggers a background process that goes and starts encrypting the entire database. When you do it with compression, that doesn't happen. You've got to do an action that causes that all to get rewritten. A little hint on encryption too. We can do this in here too, right? Be very careful about that one. I just always like to have a little caveat with that. I've been to so many sessions where people say, look, this is how easy it is to turn on. Don't be that person, and that's the end of the discussion. The thing with, if you're doing encryption, I have friends call this a CLM. It's a career limiting move, right? Unless you understand the entire life cycle of working with encrypted data, don't go playing with that, right? This is not something you want to find out about on the fly. One of the things I've spent the last couple of years doing is sort of teaching a master's class in Redmond, and most of the people that are in that room are senior field engineers and senior product engineers, people like that. One of the things I used to get them to do for fun was to try and do things like set up mirroring on an encrypted database, and that was entertainment for about a good hour or so in the middle of the class. And the reason, though, wasn't the mirroring, is they couldn't work out how to restore an encrypted database on another server. So do not find that out when something's going wrong, right? If you're going to look at encryption, practice. Go right through the whole thing, including restoring on other servers, because you need to know how to back up certificates. You need to know how to back them up with the private key, and so on and so on. This is not something you can afford to learn later. All right. Now, instant file initialization is also another one that's very useful, and it's not enabled by default. But normally when SQL Server gets space from the operating system, it says, hey, give me a bunch of space, and the operating system says, just hang on a sec, and zeroes out all the data before it gives it back, because it's worried that otherwise it's a potential security hole where it's giving you data that is whatever happened to previously be on the disk. Now, that is still a security concern. I mean, if I had a SQL Server box and I enable this, if I had an administrator that was kind of cluey, yes, they could sit there with commands like dbcc page, read the contents of the pages and see what was actually there, right, previously. But that's about the limit of what the problem is. Now, in the case of the Azure one, not so much of an issue here. But it's really important that you enable this. Now, the way you do it is you have to enable perform volume maintenance tasks as a policy for the account that SQL Server runs as. By default, it doesn't have that, as long as you're not running as an admin account or something as a service account. If you're doing the right thing, it doesn't normally have the capability of doing this. Now, once you enable that, it affects not just when file growth occurs, it's lots of other things. If I say create a database, it's got to get all the space. If I do a restore, the very first thing it normally does is goes and reclaims all the space it needs to do the restore. That can take a very long time if this is not enabled. When you add new files, or obviously when a file grows. Generally we want auto grow enabled, but we don't want it to ever occur. You want to grow files manually yourself, but you leave auto grow on just in case something goes wrong. And of course, never ever enable auto shrink, right? We usually joke that should be renamed as auto fragment my file system, right? It's just an option we'd love to see disappear out of the product. All right. Now, in terms of TempDB, as I said, don't use Drive D for this. Now, I've seen people tempted to do this. They go, well, look, it's a temporary thing. Now, there's a couple of issues with this. One is that the server won't start up if it can't access TempDB. That's just a fact of life in SQL Server today. Now, what can happen, though, of course, is this would normally be in a path somewhere inside the D drive if you did this. And of course, if you're following the right security things, where the SQL Server service is a low privilege account, it doesn't have the capability to go out and create a folder in the root of the drive anyway, right? So this wouldn't work if the drive is clear. And so now you can get around that. You could build something that runs at startup that goes and looks to see if it's there and builds the folders and does all that stuff before SQL starts. But just don't go down that path, right? The other thing we found is that the variability of the performance of that D drive is such that it's better off being on the C drive if you've only got one anyway. Or, ideally, if we've got sort of additional data drives, plant them over the top. Now, you still need to follow TempDB best practices, and I put a link in the notes here to where they are. They really haven't changed in the last versions. The main thing about them is making sure you have enough data files. And so in the case of TempDB, it's very different to a normal database. There's a few pages right at the front of the file where it stores details of objects and space and things like that. Now, in a normal database file, when you create a table or something, that happens rarely. It's got to lock those couple of pages. In the case of TempDB, though, people are often creating enormous numbers of objects, and it goes through that same thing. And so what happens is it's really, really easy to end up with latch contention or lock contention on those page free space and SCAM and so on pages at the front of TempDB. If you look at SysDM OS weight stats, the view, you'll see a weight stat that says 2 dot something or other. Guaranteed you're in that territory if you see that, because database 2's TempDB. Now, so the recommendation is, they said add one file per scheduler and keep them about the same size so it does a round robin. Now, the current recommendation we normally tell people is up to 8 processes, add one, and then beyond that, don't just keep adding files because it gets harder to manage. Then look for contention. Like, look at the weight stats, see if you're getting issues on that. If so, then start ramping up additional files. But the thinking is that if each scheduler has its own file, then they're just not going to trample over the top of each other. And as it's only an issue for TempDB because that's the only place where you're sort of rapidly creating and destroying objects. The other databases, it just doesn't happen. Now, if you look at monitoring and troubleshooting, if you're looking at the I/O capacity, SQL I/O is still a good tool for doing this, even in this environment. Now, there are several tools in this set of undocumented, or so not undocumented, but unsupported tools. There's one called SQL I/O Sim that was part of the I/O stress stuff in previous times. That's a really good tool for on-premises work for just shaking the life out of a system, particularly before you install SQL Server. I've seen it sort out and find enormous numbers of problems, particularly in on-premises where you get maybe complicated SAN environments with multi-path I/O and things like this. Stuff can go wrong, and SQL I/O Sim does a good job of shaking out a lot of those things because you don't want to find out about that when the system's running. I mean, for example, with where you've got multiple paths to the I/O, I've seen situations where SQL Server writes out one path, reads from the other path, and what it gets back is a previous version of what it wrote out here. You know, like things like this, you don't want to be in that territory. And in fact, it's so common, that sort of thing, that in the since SQL Server 2008, they've actually put checks in the back end of the product. So they checksum the pages, and every time they write a page out, they keep a least recently written out page numbers and checksums. And when they read it in, the first thing to do is to see if the checksum's still the same, as the one they just wrote out, because this sort of thing can go wrong. And so SQL I/O Sim is good for sorting that out, but it's not good for a benchmark because it's not repeatable. Every time you run it, it does sort of things in a fairly random fashion. And it does SQL Server types of I/O, but not using SQL Server. So you can't sort of use it to benchmark. Where SQL I/O, I can go in there and say, these sort of commands, I can say, I want to test 8K reads, I want to test 8K writes, and have it just bash the life out of the system to find the bottlenecks in those particular types of I/O. Now, there is also another one, a third-party one that, again, a non-Microsoft one. There's one called Iometer, I-O-M-E-T-E-R, and it's another interesting tool in that it allows you to do a variety of these types of I/Os at the same time instead of a single one. But most of the time, SQL I/O is the one that we use for doing this sort of benchmarking. Now, there's a bunch of useful DMVs. Of course, most of them started appearing in SQL 2005. They started adding the DMVs. SysDM OS wait stats is useful for finding out what the system's waiting for. It's good for finding those sort of contention things we talked about before. For expensive queries, SysDM exec query stats, That's the one that comes up in the activity monitor stuff inside Management Studio. SysDM.io Virtual File Stats is the one that allows you to get good access to each file in SQL Server and see how that's responding. Exec requests gives you details of each request that's currently executing. It has hash values in there as well that you can use to drill back and find which piece of SQL text is executing and find what the query plan is associated with that. Getting used to working with those DMVs is a good thing. For object contention, SysDM OS Spinlock stats. But IO Virtual Stats is probably the most useful for when working with IO. So the first thing, if we're looking at measuring IOs per second, the counters we're looking at there, it's called disk reads per second, disk writes per second. And of course, if you're not getting that up high enough, then adding additional data disks is quite linear if you can spread the load appropriately in an Azure VM. For latency, we look at average disk seconds per read or write. That's the measure of latency. Average disk bytes per read and write is giving you the average block size of what's being read and written. I see a lot of people focus on queue length. Most of the time, queue length is completely irrelevant, right? You'll find a lot of old documentation that says, oh, queue length's bigger than 2 or scary and so on. Look, there was a time where if we're working only with direct attached storage, that's the case. As soon as you're in like a SAN environment or something like that, the whole design of it is to get those queues up really high. So it's just a completely meaningless thing to be looking at those numbers. And of course, disk read bytes per second and write bytes per second is a measure of throughput. In addition to these, not mentioned here, but there's SysDM OS performance counters. And rather than having to go off into perfmon to find all the sort of SQL Server related counters, they've now returned them as a DMV as well. So if you look at SysDM OS performance counters, you'll find that you can build things in SQL that then monitor what's going on in performance counters without having to run off and do WMI and all these things to go off and query that from in the operating system. Look, for monitoring, as I said, latency, I showed you how to do that in Management Studio. Traceroute, of course, for the network focus, still an issue. That'll tell you where the delays are on the path to the center. So if you're trying to find where the delays are occurring, that's useful. There's a free tool from TechEd called PSPing, which is a PowerShell one. That's worth a look as well. That's pretty good. If you're looking at the SQL Server KPIs out of perfmon, percentage processor time, and doing that for total or for individual instances is useful. And for SQL statistics, there's batch requests per second is usually a pretty good one, looking at maximum and average of those. But as I said, again, they are visible out of SysDM OS performance counters instead of having to run off and go to perfmon to grab that. Now, the storage subsystem, an upside of using that for our disk subsystem is that the storage subsystem also has monitoring available. And so we can go in and configure in the blob store either minimal or verbose. Now, the minute you choose it, it gives you a warning going, hey, this can have a pricing impact. All they're trying to tell you is that it gets stored as well, right? So it starts to consume space. But you can have a good degree of how is this storage being used, again, blob by blob, where you can start to see how that's affecting. Now, this is a good story as well. Now, the KPIs, it gives you a number of containers, number of blobs, number of requests, the total amount of data going ingress and out, egress. You get charged for data that leaves the data center. Data within the data center, you don't, right? So, but that's another part of the additional things that get added up. Server latency, failures, things like that all get recorded as part of these metrics. They've got some performance charts on the dashboard that show you how the storage is performing. It's got summaries there of CPU percentage, disk reads, all that sort of stuff from the storage account point of view. But you need to enable that and then let it run for a while before it starts to collect the data. Now, we've also got a white paper that, again, I was a reviewer on this one. It's called Performance Guidance for SQL Server in Windows Azure Virtual Machines, that talks in great detail about all the stuff that we've been talking about in this session today. Now, I'd encourage you, again, to go and grab the white paper and sort of work through that. And it has sort of rationales for each of these different things. It's got a detailed description of how each of the different caching options work, there and there as well. I've put in here, just for reference, obviously not to read it here now, but details of how you could go off and do further reading on this. First up, around getting your head around just infrastructure as a service in here. Also, put a link there for how to then start looking at high availability and disaster recovery based around this. A number of links that cover off info about how to work with Azure Storage. And finally, some performance-related white papers that are directly related still in how we're working inside an Azure VM. If you have an MSDN subscription, I mentioned the guys this morning, go and activate the Azure benefits. It gets you a couple of $100 of Azure credit that you could use to go and learn to do this stuff. So again, the wonderful thing here is you don't need to have your own infrastructure to do it. Just go and spin it up. If you forget about this till you leave later and you don't have it, just look for my blog, just Greg Lowe blog, and I've put a post in there where it's got links off to the page where you can go and do this. And at the moment, as I said in the earlier session, they're giving away an Aston Martin if you do it by the end of the month to somebody who enables those benefits. And as I said, I would desperately love to see them packing it up and shipping it off to Australia. I would love to see an Aston Martin doing the rounds of the country. So. Now, in terms of related content, we're getting towards through a lot of these sort of sessions. Down at the demo stations around in the exhibition area, there's a lot of that stuff you can be shown. I will be most of the day either in the community section down in the exhibition area or in the first level in the sort of tables that are up the top there. I tend to be there a lot of the day quite often. Look, I'll be around the whole rest of TechEd. Please feel free to just come along and have a chat, and yeah, don't be a stranger. So look, I encourage you, please stay in touch. Love to hear from you, love to hear how you're going with this. I always like to see lots of feedback on how this is working for you and so on. And I thank you very much for being here today and for choosing to come along. Thanks, guys. So.